Welcome to qnawire.
We know that we are going to apply the conservation of angular momentum before the collision. So we can say L before collision will be equal to the angular momentum after the collision. And that M times L over 2 times V, this would be equaling the moment of inertia of the rod plus the moment of inertia of the putty multiplied by the angular velocity. And so we can see that the angular velocity would be equaling to the mass times the length times V divided by 2 times the moment of inertia for the rod plus the moment of inertia for the putty. We are going to then apply the we're going to apply the law of conservation of energy before and after, rather after the collision and the top of the swing. So we can say that the energy after the collision would be equal to the energy at the top of the swing. And so we can say that essentially the kinetic energy after the collision will be equal to the potential energy at the top of the swing. And so we can say 1/2 times the moment of inertia of the rod plus the moment of inertia of the putty, multiplied by omega squared, which we had found previously. This would be equal to the sum of the masses multiplied by GH. We can say that the height of the center of mass would be equaling the moment of inertia for the rod plus the moment of inertia for the putty multiplied by omega squared, the angular velocity squared, divided by 2 times the sum of the masses times the acceleration due to gravity. And we can now substitute the height of the center of mass would be equaling, this would be the moment of inertia for the rod plus the moment of inertia for the putty divided by 2g times the sum of the masses, and then multiplied by the mass LV divided by 2 times the moment of inertia for the rod plus the moment of inertia for the putty. This would be squared, and so this would be equal to m squared L squared V squared divided by 8g times the sum of the masses multiplied by the sum of the moments of inertia for the rod and the putty. And so we can then say that we can substitute now for the moment of inertia for the rod and the moment of inertia for the putty, and we can say then the denominator 8g times the sum of the masses multiplied by ml squared over 3 plus m times L over 2 quantity squared. This is specific capital M, and this is lowercase m. And then for the numerator, we have m squared L squared V squared, and so this is equaling m squared V squared divided by 2g times the sum of the masses multiplied by 4/3 times m plus lowercase m. And so we find that the height of the bottom would be equaling 2 times the height of the center of mass, and this is equaling m squared V squared, and then essentially this 2 cancels out with this 2, and we have g divided by the sum of the masses multiplied by 4/3 m plus m. This would be our final answer. That is the end of the solution. Thank you for watching.